July 19th, 2010, we're at North Shore Country Club with Dr. Tom Voigt, University of Illinois Turfgrass Extension Specialist. Tom's worked here with us for quite a number of years on various projects, one of them being this Bentgrass variety trial that was sponsored by the GCSAA, NTEP, and the USGA, and Tom was the one that oversaw the study here. It was a 5-year commitment, and Tom, why don't you tell us a little bit about what we learned over the years here?
Well, first I'd like to thank the North Shore membership and grounds crew for being a great partner on this project. We have a green that we planted in 1997, a research green with 18 different varieties of creeping bentgrass, and it's still a good research subject. It's still in force. This is hugely unusual. Most turfgrass research goes anywhere from 2 to 5 years, and to have a green that we can rate 13 years after planting is a phenomenal benefit to the turf industry, and it's a great opportunity to see how these grasses do long term. As you look at the grasses, you'll be able to see how the grasses in fact resist invasion of weeds, how they resist invasion of mosses, how they segregate, meaning that you can see little patches of different kinds of grass. So this is again a great opportunity to see how things go long term. We're very fortunate at the University of Illinois to have this opportunity to work with you guys here at North Shore as a great partner and a great collaborator. And again, I want to thank you for that.
Well, Tom, you're here today to do a quality rating on this green. We're mowing this at 95 thousandths of an inch with a John Deere walking greensmower. It's a fixed head, so it's a very true to height mowing height, and very stressful mowing height, one that we never would even consider doing out on our old bent POA greens. It just wouldn't take it. And some of these cultivars are showing some true value here with this ultra low mowing height, while others are starting to fall apart.
Look at on this half of this plot, you can see the little yellow green spots are POA invading.
Right, you can see the poania starting to move in.
And that is shows that this grass is not very competitive with it, whereas some of these other cultivars are much more competitive and will resist invasion.
And what's interesting here too, Tom, we can see the different genotypes, they call it. You can see this is one genotype within this cultivar, and here's another one that really tends to be very tight, and so tight that the poania is having a much harder time getting established in this genotype versus this one.
But also you can see that this one is coloring, losing its green color a little bit, and perhaps it's just not as competitive at that mowing height as some of the other grass.
So here's the old standard Bentgrass. You can see a lot of more segregation.
You can see how coarse texture, now horizontal rather than vertical, the grass blades are growing.
Right. And again, more poanias moving in on this variety. Compared to the A4, but still, surprisingly, this grass is still holding up okay. I mean, this is a very low mowing height, one that would be typically used perhaps for like a US Open type event and not for daily golf. So I'm still pretty impressed, I think in large part because all these are growing on a properly functioning USGA root zone.
Right.
But it is very interesting and a lot of fun to work with Tom on these projects because we get to see firsthand under our conditions what these different grasses, what their personalities are. Tom's also got the upgraded variety trial over at our other chipping green that he just finished, and we're just one season under our belt with that one, right, Tom?
Yeah, we're in the middle of the second season.
Right. So we're collecting data there too on some other newer cultivars that aren't included in this one here. So stay tuned. Thanks, Tom.
Thank you, Dan.
So to try to get a feel for the texture and the density of these grasses, to the left is Pure Distinction, then it goes to 007, Flagstick, Mackenzie, and then Bentgrass. So let's see if we can hold these up. So there's Pure Distinction compared to 007. Pure Distinction's finer. So we're trying to get a feel for real close side-by-side comparison. So Tom, we have, let's identify them first. We have from left to right then is, that one's Pencross, right?
Yeah.
Pencross. Then I put Mackenzie, Flagstick, 007, Pure Distinction.
When I look at these, I see the little bit wider leaf blades and more horizontal growth habit on the Pencross, which would be indicative of, I mean, that's one of its main characteristics. Can see that these other four look pretty similar texture-wise. They all seem to have a more upright growing habit. We see a little bit more blue-green, or more emerald green here. Maybe a little more blue-green here and here, a little more olive green there. Although I'm not sure that you're going to see a little brighter green on that one. So I think you've got some...
and what about, would you say, the texture and the density? See how?
I think all four of those are vastly superior to the old style of Pencross, and they all look good. And in the plots that we're standing on, we're not seeing any... not seeing dollar spot on any of them, are we?
That's not. It was in here earlier, cleaned up now. But
yeah.
If the way I kind of would also describe it is Pencross is like kind of have an open canopy.
Yes, yeah.
And Pure Distinction is extremely tight canopy.
Yeah.
Where the other ones are tight, but seems like Pure Distinction. You see the top of the leaf blades almost across the sample. The other ones you can kind of see, especially this one, a little more prostate growth.
Yeah.
Obviously, Pencross the most, but
I also think that these tight, dense bentgrasses are going to be more resistant to invasion by POA seedlings. They're going to be able to outcompete them, and with the more upright growth, they may be pushing the seed heads of POA plants upright, which would mean when it's mowed, they'll be removing seed heads more readily than it would from Pencross.
They are different, but depending on how you look at it and what time of the year it is, sometimes it's hard pressed to tease out that difference.
Well, I think mixing them also, because every putting green has multiple environments, and you've got 18 in-play putting greens, by using a blend of several different types, you're inclined to have one grass that one of the genotypes or one of the grasses in there is going to do well in pretty much any of the conditions that they're forced to grow in.
Here we're in our greenhouse. We're just we collected some bentgrass, individual bentgrass plants off our very old greens built in the early 20s before we renovated. You can see how there's different growth characteristics of the different bents that I thought showed good tolerance against POA. That's obviously survived all the weather patterns we've had since the early 20s, all the chemistries thrown at it. So you can see right away how this one here is a pretty good biomass producer. This one here stays pretty thin and wispy. This one's really dwarf and compact. This one here tends to be a little more spreading. So plant genetics is a very important, obviously, factor in not only selecting what cultivar to plant, but also the impacts it has on sustainability, inputs that would be required, and cultural practices. So it can impact just about everything: playability, your budget, and some of the things that you're going to be married to. There's a good debate out there on whether to plant individual cultivars versus blends. I think bentgrass is cross-pollinated, so technically there is some variations within a bag of seed that's marketed as a single cultivar, unlike bluegrass that's self-pollinated. So bluegrass, the tendency to blend or to have a mix is stronger because the genetics is much narrower than, say, creeping bent that's cross-pollinated. That's why you always get some level of segregation regardless of the cultivar. But that being said, I think there's still room for debate on whether or not inviting other strong cultivars that could add to the depth of diversity that could tolerate other more chronic pressures that create stresses on the plant. So for example, when I talk about disease pressure, I call that an acute situation where you abruptly get a disease outbreak, and those situations we documented here, for example, that your blend's only as good as your weakest link. So you can take something like flagstick that's really good against dollar spot and blend it with a cultivar like, let's say, the old 1020 or Crenshaw that's known to be dollar spot prone. You throw those two together, and now you just drag that blend down to the lowest level in dollar spot susceptibility. But until science proves other, I'm going to go with the idea that plant diversity could help with other practices that are more chronic and subtle, like various types of cultural practices, wear tolerance, shade tolerance, even heat, cold weather tolerance, those things that the type of pressure that's applied on it is demonstrated slightly differently than these acute disease issues. Maybe there's nematode issues, tolerance, you know, so giving the standard turf some diversity and let survival of the fittest, I believe, has some merit. But that being said, we're lucky to have 3 full NTEP trials that Tom Voigt oversees with monthly ratings, and we're going to look through our Bentgrass selection tool now and go through some of the thought processes we made in the very challenging process of cultivar selection. Preparing for our new greens, we put together this Bentgrass selection tool, kind of like what Leah did for seed research, but we tried to expand on some other aspects on plant genetics to help us fine-tune the selection. There's so many good bentgrasses out there. Frankly, there's at least a good half a dozen of them that would do very well, but one would still be slightly different than the other in some of these different categories, like organic matter generation, the competitiveness against POA, spring green up, disease susceptibility, and playability. So we went through the process of summarizing other data and incorporating some of ours. For example, the quality rating found on the NTEP trials, for example, where they assess color, density, vigor, to kind of give a 1 through 9 rating, 9 being the highest quality. So we took the quality ratings here at North Shore Country Club from 2009 to 2013 that Dr. Tom Voigt from University of Illinois came out monthly and assessed, and then the quality ratings from Rutgers, which tends to be a hot, more humid environment, so it kind of like is a midsummer vision of under our conditions. From 2012 to 2015, and then we took Purdue, which is again further south, a little warmer climate, a little longer season, and we tried to understand from these 3 different locations which varieties in quality rating, which cultivars performed the best according to the 3 researchers that evaluated them. Then we took organic matter. This is something we did in-house. So we did a loss on ignition at 360 and 440. We also did some analysis on the carbon to nitrogen ratio, the CN ratio. We wanted to just take a look at that and see what the different CN ratios are. We found that kind of interesting, with the concept there that the broader the range of the CN ratio, perhaps with the more carbon as it associates with nitrogen, perhaps the more persistent the organic matter might be. That's just a concept. And when you get up past, say, 30 to 1, you really have to supplement some nitrogen, for example, for that carbon to become digested by the microbes. They just need that nitrogen for their amino acid and protein production to break down the carbon. So you can see like A1 with 26.56 is pretty significantly different than, say, T1 at 16.1 or 6 rather. So that tighter CN ratio would be more attractive probably than the broader one. And the organic matter loss on ignition, we really tried to focus on that. Not plant genetics. There is a difference in how much organic matter they produce, generate, whether it's in the thatch or the mat layer, it's all near that surface. That's where the action takes place. So we really try to dial that in tight, and Brookside Labs was kind enough to do this analysis for us. Then we compared that to the only other reference we found from Arkansas that did a loss on ignition at 440 down in there, and they focused on the top half inch, and that it was interesting to see very similar trends and patterns. I believe their stand of turf was younger than ours, but very similar trends. A couple outliers, but it was interesting to see and encouraging to see that with these two sets of data and the limited information that's out there on the amount of carbon that these different cultivars generate, all else being equal. In other words, they're all managed the same on our site, and on Arkansas I'm going to assume that all these cultivars are managed the same. Then firmness and bloating or scalping potential is another one we really try to understand, because we're going to try to manage these new greens with very little to any sand top dressing. We want to try to recycle the sand as much as possible and remove the organic matter instead of burying it, causing potential problems down the road and shortening the lifespan of the root zone at the high level of function at least. So Purdue had a firmness data set that we incorporated with some of these cultivars. Bloat, scalping, there was a little bit of information out there on that, and then the verticutting tolerance. We did this in-house, and we rated this to see how these different cultivars tolerated weekly, pretty aggressive verticutting to, again, remove some biomass near or at the surface, just below the surface, kick up some sand, work the sand back in, and blow off the organic debris and remove instead of bury. So bloat scalping, here's a photo for example. You can see right here how this cultivar tended to puff up, I guess is another term that we use. Here's the example of the verticutting. This was set at a ½ an inch. We used the Moreto, or we used the True Surface, but we're also using the Moreto. Next year we're going to use both of these machines. One spins backwards, the other one spins forward, so we can dial in the level of aggressiveness both by how it spins and by how deep we go. But boy oh boy, does this machine kick up the biomass, especially at first, and then as you continue to use it, it settles down. But the beauty is right behind it, when you mow or roll it, the golfer doesn't even know you did it. So I'd rather remove this biomass, even though a lot of it's living biomass, which I still think adds to the organic material near the surface that plugs up the pore space between the sand particles. We often reference that organic matter as all being dead. The truth is much of that's still living. So to physically remove it, it's going to regenerate and grow back in, so it's going to be a chronic practice to keep that top surface breathing and open, so to speak. But we believe strongly that this is going to be an important part of our new greens and managing them moving forward. So here's the low tolerance, for example. This is probably Bentgrass, because Bentgrass really didn't tolerate a very high level of it. Here you can see that's probably Pure Distinction, because Pure Distinction is very tolerant of this type of verticutting. So it's a form of wear. It's a wear tolerance issue in part. Spring green up, I'm not quite sure if this really relates to biological activity during cold weather. I wish it did, but the information that's out there, we have our own on site, the spring green up in North Shore, the spring green up in Michigan, we took their data set, and up in Minnesota, figuring that on the other side of the lake, in Lake Michigan, it tends to be more mild and cloudy there with the lake effect, and certainly in Minnesota being further north. So we kind of dialed in the cultivar strengths on their spring green up. We feel that's important because the long, cloudy, cold, damp springs we tend to have in Chicago, and when you come from POA going to Bent, there is a difference. That POA is ready right at snowmelt pretty much to get going. Bentgrass takes a little more time to get moving in the springtime that needs warmer temperatures. So early spring diseases was also looked at. We looked at in Purdue, which probably has a pretty low pressure, but we also looked at Iowa as snow mold, and dollar spot. That's obviously a big one for us here. We're pretty dollar spot prone, so we looked at Rutgers. That tends to have a higher disease pressure. Indiana again. So we have 2 data sets there. Brown patch, we looked at brown patch as well from Rutgers, and Pythium. I feel Pythium's a little different. I mean, I think there's probably a cultivar difference, but I'm also wondering that if our Pythium problems come from our irrigation water. Many ponds like ours are muck bottom ponds, and Pythium tends to, you tend to re-inoculate this system every time you irrigate. So I just wonder if Pythium and the pressure relates in part to the irrigation water. And then wherever we could, we try to incorporate data from blends, because I tend to be a person that believes in blending. I know it's a good argument to go either direction. I believe that blends, as long as they're well designed, could add a little more diversity that might be beneficial for environmental stresses. Diseases, I'm going to say blending is more complicated. These more acute, quick pressures being from disease, blends are kind of odd. Your blend's only as good as your weakest link. So you have to be really careful. For example, flagstick is known to be really good against dollar spot. You put a cultivar that's slightly more or slightly prone to dollar spot, you just now brought that blend down to probably that lower level. It's going to weaken that flagstick's ability to ward off dollar spot. So with diseases that I call acute pressures, environmental pressures, that's looked upon a little differently, but other pressures like wear tolerance, like shade tolerance, like cool weather growth tolerance, those kind of environmental pressures, I think blends lend themselves a little bit to be a better stand. It's just my opinion, but there's opinions that say other. Localized dry spots, we've got some information from Rutgers on that too. POA competitiveness at North Shore and Pennsylvania and Wisconsin is included in our data set, and so the POA competitiveness and the organic matter data that Chaz put together are two that are pretty unique, that really originated here at North Shore, at least maybe not the first site, but very early site to get that kind of information documented. Here you can see clearly the amount of competitiveness just through plant genetics, and this is with POA cure treated. So we did a data set on POA cure tolerance. I can say that under the labeled rate, the proposed label rate and frequency, all the bentgrasses tolerated POA cure well. But you combine the POA cure with plant genetics, and you got a more favorable outcome as far as its ability to withstand POA invasion. Pure Distinction was one of our rock stars, for example, in POA suppression. Is very competitive against POA. The other thing is, because of its color and density, it's also pretty good at camouflaging POA. So even if you get a little bit of POA, it's really hard to see it in there. Which, if you're hand picking, perhaps that makes it a little more complicated. But it does compete well against POA, but it also tends to mask it. Here's another cultivar, for example, where we rated it as a 5. We did these ratings in-house, obviously. This is another data set unique to North Shore Country Club. And here's A2. It gives you an idea of the differential, treated versus non-treated.